Hello everyone, welcome to 721D1. Today we're going to be talking about remembering transformations of graphs. So way back in the fall semester we learned how to take several different types of graphs and just move them around, moving them up and down, left and right, stretching them and compressing them and reflecting them as well. So we're going to review how to do that by looking at the graphing form of a function, and then we're going to review the parameters a, h, and k and understand how each of those parameters controls the graph. And then we're going to use the graphing form of a function to graph a function. All right, so we're going to see all three of those in our lesson today, and you're going to want to make sure that you know how to do these things before you move on to the next lesson, because we're going to be doing this exact same thing but with the trig graphs, right? So you have to remember those sine and cosine functions that we graphed before spring break. We're going to be taking those sine waves and those cosine waves, and we're going to be moving them up and down and left and right and all different directions. And so you pretty much already know how to do that because we've done it with parabolas, and we're going to be doing it with those functions as well. All right, so just remember that the graphing form essentially looks the same for every function. So we see the graphing form here for a parabola. We're going to be focusing on parabolas today for review purposes. But remember that the a, the h, and the k in the graphing form essentially look the same for any kind of function, whether it's a cubic function or a square root function or a sine function, all right, which we're going to be looking at tomorrow. All right, so this is what the graphing form looks like, and you notice our a, our h, and our k values. These are the three parameters that control the movement of our graph. Right? And the a parameter, this number that's out front of the parentheses, controls the stretch and the compression of a function. Right? So for a parabola, this is what makes the parabola skinnier or wider. Okay. The h parameter, right, that's inside of the parentheses. This controls the left and right movement. So if I wanted to take my parabola and slide it to the left or slide it to the right, this is the number that controls that, right? So if we saw like a 2 here, that would mean that it moved to the right 2 if it were a -2. So remember, minus moves to the right, plus moves to the left, all right? And then we have the k value. This controls our up and down movement of the function. So if I wanted to slide my parabola up or down, this is the one that does that. So if we saw like a +3 here, that means our parabola would go up 3 units. All right. So just a quick review of those three parameters. We're actually going to use those now and see what these transformations look like. And like I said, a lot of this should look very, very familiar. All right, so here in, one more thing before we continue on here, just a quick reminder that the sine of a, right, so if we're looking at this a parameter out front, if there was a negative here, that would actually flip the parabola or reflect the parabola over the x-axis. So make sure you look for a negative in front of that a. If you see one, that means there's been a reflection, all right, which actually pops up in our first problem here. So we'll see that right away. All right, so in our first problem, our goal is to graph this function right here, y equals -x squared, and we want to do it using the transformations, right? So we see that negative out front of the x squared, and this indicates that there has been a reflection, right? So when they say list the transformations, we're going to say, okay, well, the only thing we're doing here is reflecting over x, because there's nothing else. There's no h, there's no k, there's no stretch factor. So this is the only thing that is happening to the parabola that we see here. So the parabola that's graphed in each of these problems, this is just plain old x squared. Right, so we haven't done anything to this parabola yet. We have not moved it left or right or up or down. We have not stretched it or compressed it, and we have not reflected it. So this is how it starts. And now we're going to take this parabola and we're going to do this to it. We're going to reflect it over the x-axis. And I like to do this point by point. Okay, so you'll notice that we have like these 5 major points here on the parabola, and this is just to help us shape the parabola. So when I look at this point right now, it's at 1, 1, and I want to take this point and I want to reflect it over the x-axis. This is the x-axis right here. Okay, so notice that if I'm going to reflect over the x-axis, notice that it is 1 unit away from the x-axis. So I go down 1, which means it needs to go 1 unit to the other side of the reflection line. So this point is going to move here. And then if I were to do the same thing to this point, it is 1 above, right? So it's going to go 1 below. So I'm going to have another point right here. And then this point is on the reflection line, so it's going to stay put. It's not going to move anywhere. It's 0 away from the reflection line, so it's going to stay 0 away from the reflection line after it's been reflected. Now this point up here is 1, 2, 3, 4 above, so it needs to go 4 below. 1, 2, 3, 4. So it's going to go right here. All right, and then we're going to do the same thing with this one. So it's 1, 2, 3, 4 above. So it's going to go 1, 2, 3, 4 below. And you see your parabola take shape, right? The reflected parabola. So I'm going to go ahead and draw my parabola through those 5 points. And my parabola is a little sloppy because I'm drawing with this confounded digital pen, which is really annoying, but you can kind of see there's our reflected parabola. I got my 5 points in, so this parabola, the original parabola, has been reflected to my new pink parabola down here. All right, so we successfully graphed y equals negative x squared. All right, so let's try it again. This one we have a -1. It's inside of the parentheses, right? So if I'm looking at my my graphing form up here, right? The variable that goes, or not the variable, but the parameter that goes inside of the parentheses here is the h parameter, right? So this is h, and h controls the left and the right movement of the function, and so it is a -1. So the transformation that's taking place here is that it is moving right 1 unit. Okay, so it's going right 1. So I'm going to take this parabola that I see here, and we're going to shift it to the right. And I'm going to do that point by point. Right? So this point is going to go right 1. Right? So it's going to move right here. This one is going to go right 1. So it's going to move right here. Right? And this one's also going to go right 1. So it's going to move right here. And then this one's going to go to the right 1. So it'll move right here. And then this one will move right 1. So it'll be right here. And you see your new 5 points. So I just have to draw my parabola through those 5 points. And let's see if I can do this with my pen. And there it is. All right, so you see the original blue parabola, and it has been shifted to the right 1 unit. All right, so we have successfully graphed x minus 1 squared. All right, let's try it again. Let's do a different transformation. So this one, we're looking at this x squared plus 3. So if I go back to my graphing form, I'm thinking, well, it's not inside of a parentheses, right? That plus 3 is just a plus 3 on the end, right? So we're looking at the k parameter, right? So when I look at this plus 3, this is k. So this is telling me that it is going up 3 units. Okay, so I'm going to take this parabola and I'm going to move it up 3. That's all I got to do. Okay, so then, again, I'm just going to do this point by point. So we can start with this one down here. This point is going to go up 1, 2, 3, so it's going to go right here. All right, so this point moved like this. Right, moved up 3. And I'm going to do that with each point, right? So 1, 2, 3, I'll have another point right here. And this one, 1, 2, it's going to go a little off the graph, that's okay. Right, so we can eyeball that one, goes about right there, and that's going up 3. And let's do this one, so 1, 2, 3. And I'll draw the arrow. I don't know if the arrows are annoying or not, but let's see, 1, 2, 3, so it'll be about right here. Right, and then you see your 5 points there. We just got to draw the parabola through it, and I missed that last point. That's okay. You guys get the idea. All right, so there's my new parabola shifted up 3 units. All right, so it's pretty simple, right? Look at your equation, figure out what transformations are happening based on what your equation says, and then go do it to the parabola that you see in the graph, right? So we have this parabola here, and I like to do it point by point. I find the 5 major points, and then I do this stuff to it, right? Once I list the transformations, this becomes like an instruction manual. You can do it 1 step at a time, or you can do a couple steps at a time if you want to save some time. But essentially, just follow your instruction manual. Follow the list of transformations that you write out, and move each point according to that list. All right, so when we get to something like this has several transformations in it, right? So we see all of it here. We see this 2, that's the number in front of the parentheses, that's our a value, this number in front or this number inside of the parentheses, that is our h value, and this number here on the end, that is our k value. So it looks like we have three transformations happening, so let's go ahead and list those out. All right, so if I start with the a value here, this 2 means that the parabola has been stretched by 2. All right, and then the +1 inside of the parentheses, right, that's our h, that controls left and right. So since it's a +1, it's going to go left 1. And then for the last one here, this -1, that's a k value, so that means it's going down 1. Right, so now I have my instruction manual. I know what I want to do to this parabola. So I'm going to go do it. And when we have multiple transformations at once, you kind of want to pick, what am I going to do first? And decide whether or not you're going to try and do this all at once, or are you going to try and break this down step by step. So what I'm going to do is I'm going to do this first, and then I'm going to do both of these at the same time. All right, so I'm going to do the stretch first, and then I'm going to go left and down 1 at the same time. All right, so let's take care of the stretch. All right, so when we stretch something, it's kind of weird. Right now, this is the original parabola before it's been stretched, and you'll notice to go from this point to this point, we go over 1, up 1. All right, so when a parabola gets stretched, rather than going over 1, up 1, it's going to go over 1, up 2, because it's been stretched by a factor of 2. So this point becomes this point. Okay, and then for this one, right, in the original parabola, we go over 2, up 4. Well, we need to double that, so we need to go over 2, up 8. Right, so we're going to go over 2, and then 1, 2, 3, 4, 5, 6, 7, 8. We're going to go off the graph a little bit, and that's okay. All right, so we'll be about right here. Should have made a bigger graph. That's okay. All right, this one's going to stay put. And then we're going to do the same thing over here. So we went left 1, up 1, so we need to go left 1, up 2. Okay, and then we're going to go left 2, up 8. 1, 2, 3, 4, 5, 6, 7, 8. So about right here. All right, and when I draw this new parabola, right, it's not the final parabola. It's like an intermediary parabola. It's like a middle parabola. All right, we're not done yet because we've only done step 1 of our transformations list. That was horrible. All right, there we go. Very sloppily drawn, but I have completed step 1 of my transformations list. Now I'm going to do step 2 and 3 at the same time here. Make sure you can see your points after you've done step 1, because now we're working with the parabola after I've completed step 1. So I'm working with my pink parabola. I'm going to switch colors here so that we can differentiate between the final parabola. So let's go to like a bright blue here. All right, so I'm going to do this next, right? I'm going to go left 1, down 1, and I can do those at the same time, right? So this point, right, I can go left 1, down 1, and I can put that point right here. And then this one's going to go left 1, down 1. And then this one's going to go left 1, down 1. All right, so I'm just going to all of my 5 points, right? And I'm doing step 2 and 3 at the same time. Okay, so I'm going left 1, down 1. Right? Left 1, down 1. Left 1, down 1. Just like that, every single point. All right, so I'm going to go with this one too. I'm going to go left 1, down 1. So we're going to be about right here. And then same thing, left 1, down 1. And there's my new parabola. So this blue one that I'm about to draw, that is my new parabola. Alright, again, very sloppily drawn as I'm horrible drawing parabolas with my pen, but there's the resulting parabola after I plotted my 5 new points, right? So the purple parabola was the result after the stretch only, and then the blue parabola was after we did the left 1, down 1 on each of the points, right? So the blue parabola is the parabola that results after doing all 3 of the transformations that we see here. All right, and this method of using these 5 points, it's going to be how we do the sine wave and the cosine wave. So doing it point by point is really the easiest way to go about doing this. So I would give that a practice a couple times, go through these problems, see if you can do the same thing, and then give the practice problems a try and see how you do. If you have any questions, make sure you let me know in the Zoom chat so that I can help you out. Otherwise, have a great day.